Hello learner, it is time for our SHS 3 Core Mathematics program. This is brought to you by Center for National Distance Learning and Open Schooling, CENDLOS. I am Ben. In our previous lesson, we learned about surface areas of prisms and how to solve problems involving surface areas of prisms. In this lesson, we shall learn how to calculate volume of the various prisms that we studied in our previous lessons. In this lesson, you should be able to calculate the volume of prisms. A prism is a solid with uniform cross-sectional area. Examples of prisms include cube, that's a square prism; cuboid, that's a rectangular prism; cylinder, triangular prism, trapezoidal prism, etc. The name of a prism can be determined by the shape of the cross-section. For example, the triangular prism derived its name from the shape of this cross-section. That is the triangle. The trapezoidal prism derived its name from the shape of the cross-section. That is the trapezium. Let us look at diagrams of some prisms. This is a cuboid which has a rectangular base. This is a triangular prism which has a triangular base. You can see a cylinder which has a circular base. We have the cube which has a square base. This is the hexagonal prism which has a hexagon base, and many other prisms which are not shown here. In each of the prisms, the name of the prism is described by the cross-section. Let's now look at the formula for finding the volume of a prism. As indicated earlier in the diagrams, each of the prisms has a length of a cross-sectional area. So the formula for finding the volume of any prism is simply given by the product of the cross-sectional area and the length or height of the prism. Mathematically, it is given by volume equals cross-sectional area multiplied by the length. Note, the length can also be described as the height. We shall now consider the various prisms. Let's look at cuboid and cube. The cuboid and cube look alike, but differences exist between them. For instance, the edges of the cube are the same. In other words, each surface of a cube is a square. However, the edges of a cuboid are not the same. Each surface of the cuboid is a rectangle. As you can see, a cuboid has a rectangular base, that the cross-section is a rectangle. This is a cube with a base of a square. That's the cross-section of the cube is a square. We now look at the volume of a cuboid. The cross-section of a cuboid is a rectangle. And we know from year 1 that the area of a rectangle is given as area equals length multiplied by the breadth. If you multiply the height of the cuboid by the cross-sectional area, we obtain its volume. Therefore, the volume of a cuboid is given by volume V equals cross-sectional area A multiplied by the height H. Symbolically, we have V equals L multiplied by B multiplied by H. Let us look at some examples on volume of cuboids. Example 1. Find the volume of the cuboid with length 10 centimeters, breadth 5 centimeters, and height 7 centimeters. Let's look at the solution. Volume of cuboid is equal to the cross-sectional area multiplied by the height, or volume equals the length multiplied by the breadth multiplied by the height. So from the question, we have L equals 10 centimeters, B equals 5 centimeters, and H equals 7 centimeters. So if you substitute into the formula, we have volume equals 10 centimeters multiplied by 5 centimeters multiplied by 7 centimeters. Therefore, the volume of the cuboid is 350 centimeters cube, which is a unit for calculating volume. Let's look at example 2. Find the volume of the cuboid of size 6 centimeters by 12 centimeters by 8 centimeters. Let's look at the solution. From the question, we have B equals 6 centimeters, L equals 12 centimeters, and H equals 8 centimeters. We know the formula for finding the volume of a cuboid is V equals the length multiplied by the breadth multiplied by the height. So if we substitute our figures, then we have the volume equals 6 centimeters multiplied by 12 centimeters multiplied by 8 centimeters. Therefore, the volume is equal to 576 centimeters cube. We now find the volume of a cube. The cross-section of a cube is a square. That is, the base area is equal to the length multiplied by the length. Therefore, the volume of the cube can be obtained by multiplying the cross-sectional area by the height of the cube. Therefore, the volume of the cube is given by V equals the length times the length times the length, and that will give us L cube. Let's look at an example. Find the volume of the cube with side 7 centimeters. Let's now look at the solution. The length of the cube is 7 centimeters. And we know the volume of the cube is the length times the length times the length. So if you substitute our 7 centimeters, then you get the volume equals 7 centimeters multiplied by 7 centimeters multiplied by 7 centimeters. And that will give us the volume equals 343 centimeters cubed. Example 4. In the diagram, if the diagonal of one surface of the cube is 20 centimeters, find the volume of the cube. Now, if you look at the diagram, we have the diagonal to be 20 centimeters. Now, let's look at the solution. From the question, we consider the cross-section area, which is a square. We let each side be L. So we have a face of the cube. We have the length to be L and another length to be L, and the diagonal is 20 centimeters. Applying the Pythagoras theorem, we have L squared plus L squared equals 20 squared. And if you simplify, you get 2L squared equals 400. Dividing through by 2, you have L squared equals 400 divided by 2. Then we take the square root of the 200. So you have L equals square root of 200. And that will give us 14.14 centimeters. This gives us the length of the cube. We can now find the volume as V equals L cube. So the volume is equal to 14.14 cubed, and that gives us 2,799.15 centimeters cubed. I hope that was not too difficult. Let's now look at the volume of a triangular prism. The cross-section of a triangular prism is made up of a triangle. During our year 1 lessons, we learned how to find the area of a triangle. I hope you can remember. This time around, we are focusing on the volume of the triangular prism. To find the volume of the triangular prism, we multiply the area of the triangle by the length of the prism. We have a triangular prism, as you can see. The cross section, which is the base, is a triangle. And we have the length. So in finding the volume of this prism, we use the area and we multiply by the height. The area of a triangle is given by area equals half base multiplied by the height. Therefore, the volume of the triangular prism is given by volume equals area of triangle multiplied by the length. Let's look at an example. Find the volume of the triangular prism. The base of the triangle is 8 centimeters. The height of the triangle is 10 centimeters. And the length of the prism is 16 centimeters. Let's look at the solution. From the question, we must find the area of the triangle. We have been given the height to be 10 centimeters, the base is 8 centimeters, and the length is 16 centimeters. Therefore, the area of the triangle is half multiplied by the base multiplied by the height. If we do the appropriate substitutions, then we are going to obtain A equals half times 8 multiplied by 10. And that means our area is equal to 40 centimeters squared. Squared because it is an area. Now we have calculated the base area. The next thing is to find the volume of the triangular prism. And that is given by area of the triangle multiplied by the length. So if you do our substitutions, we have V equals 40 times 16. Therefore, the volume is equal to 640 centimeters cube. We now look at the volume of a trapezoidal prism. The trapezoidal prism is a prism whose cross-sectional area is a trapezium, meaning the base is a trapezium. The volume of this prism can be obtained by finding the area of the cross-section and multiplying it by the length of the prism. The area of a trapezium, we know from our first year lessons to be half multiplied by the sum of the parallel sides multiplied by the height. We have a picture of a trapezoidal prism on your screens. The base is a trapezium and we have the length. Therefore, the volume of the trapezoidal prism is given by volume equals area of the trapezium multiplied by the length. Let's look at an example. Find the volume of the trapezoidal prism shown on your screens. From the diagram, we find the area of the trapezium. The height has been given as 14 centimeters. We have the parallel sides to be 12 centimeters and 10 centimeters. And the length is 8 centimeters. Therefore, the area of the trapezium is given by half multiplied by 12 plus 10 in brackets multiplied by 14. Therefore, the cross-sectional area is equal to 154 centimeters squared. If you use your calculators, I'm sure you can get the results. Therefore, the volume is equal to the cross-sectional area multiplied by the length. And that will give us volume equals 154 multiplied by 8. And that gives us 1,232 centimeters cube. Let's take another example. A water tank is made with a uniform right-angled trapezium-shaped vertical cross-section as shown in the diagram. If the tank is completely filled with water, how many cubic meters can it hold? Now the diagram is on your screen. Let's look at the solution. We find the cross-sectional area, which is a trapezium. From the diagram, the area of a trapezium is given by A equals half multiplied by 4 plus 7 multiplied by 4. And that gives us 11 times 2. Therefore, the area of the trapezium is 22 centimeters squared. So we can now calculate the volume of the prism, which is the cross-sectional area multiplied by the length. So if you substitute, we have volume equals 22 times 6. Therefore, the volume of the prism is 132 centimeters cubed. We now look at the volume of a right circular cylinder. A cylinder is a prism with circular cross-section, meaning the base is a circle. That is, the end of a cylinder is made up of circles. The volume of a cylinder is given by the area of one circular end multiplied by the height or length of the cylinder. The area of a circle is given by pi r squared, where r is the radius and pi is a constant. The volume of the cylinder is therefore obtained by multiplying the area of one circular end by the length or the height. So we have volume of a cylinder equals area of circular end multiplied by the height or the length. And that will give us V equals pi r squared multiplied by h. Let's look at an example. Find the volume of the cylinder shown on your screen. It has a base diameter of 7 centimeters and a height of 12 centimeters. In this question, we assume pi to be equal to 22 over 7. Now let's look at the solution. From the diagram, the diameter is 7 centimeters. So we have to find the radius first, because in the formula, which is pi r squared, we need the radius. The radius is the diameter divided by 2. So we divide 7 by 2 and we get 3.5 centimeters. We have already been given the height to be 12 centimeters. Therefore, if you do the substitution, then we have V equals pi r squared h. So we are going to have V equals 22 over 7 multiplied by 3.5 squared multiplied by 12. Simplifying that, we have V equals 462 centimeters cubed. Therefore, the volume is equal to 462 centimeters cubed. I hope that was very easy. Let's look at volume of combination of prisms. Now, this is a case where you may have two different prisms in one shape. The volume of prisms formed by combining two basic solids will be the sum of the volumes of the individual prisms. Take a look at these prisms. When we consider the diagram labeled A, it is a combination of prisms, which is made up of semicircular cylinder and a cuboid. In diagram B, we have a combination of two prisms. There is a combination of two cuboids labeled A and B. So when finding the volume of such compound prisms, we try and identify the individual prisms making up the combined prisms, and then we find their respective volumes. After that, we add their volumes to obtain the volume of the compound prism. Let's take an example. Find the volume of the prism if CD is equal to EF. Now the prism has a side of 16 centimeters by 20 centimeters. Let's look at the solution. From the diagram, we need to find the cross-sectional area A, B, C, D, E, F. And then we multiply the area by the length BG. Again, from the diagram, AB is equal to 16 centimeters. Let CD equals EF equals X. We also know that from the diagram, AB is equal to CD plus EF. Therefore, if we substitute these two information, then we are going to have 16 equals X plus X. Simplifying, you get X equals 8. Therefore, CD is equal to EF and it is equal to 8. We consider the cross-section separately. That is C, D, E, F, A, B, F, S. We have the dimensions shown. We find the area of the rectangle ABFS, which is the length multiplied by the breadth. So we have A1 equals 16 centimeters times 8 centimeters. And that gives us 128 centimeters squared. We find the area of the square CDES, and that is 8 centimeters times 8 centimeters. And that gives us 64 centimeters squared. Now we find the total cross-sectional area, which is A1 plus A2. So we have the area equals 128 centimeters squared plus 64 centimeters squared. And that gives us an area of 192 centimeters squared. We can now find the volume now that we know the area of the base, as volume equals 192 centimeters squared multiplied by 20 centimeters squared. Therefore, our volume is equal to 3,840 centimeters cubed. I hope that was very, very easy. In this lesson, we have learned how to calculate the volume of the following prisms: a cuboid, a cube, a triangular prism, trapezoidal prism, and a cylinder. This brings us to the end of our discussions on volume of prism. In our next lesson, we shall learn about the cone. I hope you have learned a lot and you will keep practicing a lot more questions on all that we have been discussing on this program. Join us again for the next lesson. Goodbye.